Hi, everyone. Thanks for joining this session about how to bootstrap your first Kubernetes experiment with App2Container. Before to start, I would like to take a couple of seconds to present us. Melina?
Yeah. Hi, guys. I'm Melina Schweitzer. I'm a game day partner solutions architect with AWS. Been working at AWS for quite a few years. And right now, I've been working, or up until now, I've been working on basically trying to fill gaps wherever we see that we have, that we need some solutions, some use cases, documentation, and so on that we're lacking for our customers. So happy to be here.
Thanks, Melina. Thanks, Melina. And I'm François Bouteruche. I'm senior developer advocate at AWS for a few weeks now. Before I was working in the same team as Melina, focusing on developers. So happy to be here to discuss about App2Container and how it can help developers to bootstrap their experiments with Kubernetes. So first, let's talk about the use case for this session. So we will discuss the use case of I Love My Local Farmer. So I Love My Local Farmer is an AWS content initiative. It's a fictional online marketplace that we are using to tell the cloud journey of a company. And this cloud journey is built on top of all the customer use case we see when we work with customer. And we had the feeling that sometimes our story was a bit disconnected. So here we wanted to create a whole story and to highlight each step that a company could face when they migrate to AWS. And right now, in this use case, I Love My Local Farmer so they have decided to migrate onto AWS, and they realize that they need to improve their software engineering practices to leverage the benefits of the cloud. And they want also to improve their practices both on premise and on AWS, because they won't migrate on AWS in one day. So they have to improve their practices both on premise and on AWS. And to do so, they decided to embrace a replatform strategy based on Kubernetes. They want to leverage the capabilities of Kubernetes to help to have better deployment or environment, speed up the deployment. So it's really about how they can use Kubernetes. You can learn more about I Love My Local Farmer on their website on ilovemylocalfarmer.io. So, Melina, just present us the architecture of the application.
Sure. So basically, the use case that we're covering here is a Java full stack Spring MVC app, which lives on a Tomcat application server. Just your traditional app. I think we're probably all familiar with this kind of architecture. But in case you're not, what we have here is a load balancer, an F5 that stood up in front of the application servers. We're running, Apache, Tomcat, the usual Spring stack, I guess. And basically that application is actually interfacing with a MySQL database that has a primary and standby architecture. So, no surprises here. I think probably a lot of people know this kind of architecture. So basically, when the user puts in a request, it goes to the load balancer. The load balancer decides using a round robin sticky session algorithm which application server should actually serve the request. So it sends a request over there, and the Spring app does its thing. Basically, we have the full backend. We have a full front end also on the app running. It's a complete full stack application. So yeah, if you like to see more details on this architecture, you can actually follow the link into one of our Medium blog posts that covers and talks a little bit more about what the app does and so on. Next slide, please, Francois.
Yeah.
All right, so so now that we're trying to migrate this customer onto AWS, so what are what have we decided? So we know that we want to do Kubernetes, and you have several options for running Kubernetes on AWS, and we basically decided to go with the managed service for Kubernetes, which is the Amazon EKS Elastic Kubernetes service. So what we have now is very similar diagram to what we had on premise, but now we have replaced some of the components with the Amazon specific versions. So for the application load balancer, we're actually going to have the managed service, which is actually it's not a service in itself. It's actually within the EC2 service, but it's going to be basically a classic load balancer sitting on AWS. For the application servers, we're going to have actually the service EKS in its place. It's going to actually talk to Amazon ECR, which is where the image is going to live, the container image. And these pods are actually going to talk to Amazon RDS, which is our database service. So for those of you that are not familiar with all these services, basically EKS is a service, a managed service for Kubernetes. And what does that mean? So whenever we say managed service, it means that we are going to sort of manage the infrastructure for you so that you can actually concentrate a little bit more on actually the logic and what's happening inside your applications. So in this case, AWS is going to be handling the provisioning, the scaling, the managing of the Kubernetes control plane. It's going to do so in a highly available manner. This means that we're going to be deploying into 3 availability zones, which is, in case you're not familiar, it's basically saying data centers. That's, I guess, what's more similar to what an availability zone is. If it's going to detect and replace any unhealthy control plane nodes, it's going to patch them for you. There's IAM integration also with the Kubernetes role-based access control as well. So we basically do some of this heavy lifting that comes with using Kubernetes. For the Amazon RDS database service, what we have is a managed service as well for databases. And what you're going to get is basically automated backups, patching, synchronous replication, automatic failover, all that stuff is sort of done. You're going to have your, depending on which architecture you choose, you can have the primary and standby architecture, that we usually see on on-premise customers. Yep. And ECR is basically where the the image is going to be registered at and live. So this is the cloud architecture, and I just wanted to make sure that you guys know that this is not the only option for running the EKS service. Actually, you can also run it on premise using the Amazon EKS distro. So this is a distribution of Kubernetes, and it has basically all the dependencies, in it built in for running on premise. As a lot of times Kubernetes developers spend quite a bit of time doing upgrades and testing dependencies and their compatibilities with each other and whatnot. And sometimes these versions go out of support quickly. More quickly than some people would like. So what EKS distro does for you is make sure that there's a bit of extended support, more than what the community usually offers, and that the package that you receive in this distro is actually all fully tested to be compatible with each other, all these dependencies and versions of Kubernetes in itself. So this, kind of alleviates some of that headache in maintaining your infrastructure, basically. All right, next slide, please. All right, so how do we go from that on-premise architecture that we showed in the first diagram to the second one? You can do it all manually, obviously. It'll be a lot of work though. So what we discovered with Francois was that there is this nifty little tool called App2Container. And what that does is basically So you install it on the server, or actually you don't have to install it on the server that's running Tomcat. You can actually also install it locally, and you can sort of remotely configure to work on the server where Tomcat lives. And what it does is it inspects the environment that Tomcat is running on. It inspects the web apps that are registered to Tomcat. So the Spring app, for example. And through a series of command line commands, basically, there's just literally, I think there's like 5 or 6. It analyzes your app that's running on Tomcat, and it basically comes up with these config files and all like that will be used by the EKS service in order to stand itself up and deploy itself. So it's actually quite cool. It will do your Docker file for you also. So it fully containerizes your app that's running right now on Tomcat on your on-premise service. So this facilitates greatly, the going from the on-prem architecture with, your fixed Linux servers and whatnot over to the cloud with, all the power that brings to your architecture. So Francois will now show us the steps to do so.
Yeah, let's take a look at how it works. So here I'm on my terminal command line. I'm using Windows subsystem for Linux. So I'm on a Windows machine running Windows subsystem for Linux. So inside Windows subsystem for Linux, I install App2Container. And the first thing we need to do is to init and to configure the tool. So it's very quick. Just run App2Container init. So as you may have spotted, I need to run this command line with root privilege, because for running all this analysis, it will require to have root privilege to analyze the ports that your application is using, or its dependencies. So yes, you need to run it with root privilege, both locally and remotely. So first thing, it asks you where do you want to set up the workspace directory. So I've already set up it before. Then it asks you which AWS profile it must use to connect to your AWS account. So basically, an AWS profile is your credential to connect to your AWS account through the AWS CLI and tool like App2Container. So here again, I've already used the AWS CLI to configure my AWS profile. You have to use the AWS CLI to configure your AWS profile. And I've already set up one profile. Optionally, if you want to go up to the deployment step, you have to provide an S3 bucket. So an S3 bucket is basically an object storage on your AWS account. So here again, I've already created an S3 bucket so that App2Container can upload the artifact to deploy onto S3 and then use this artifact to deploy my Amazon EKS cluster and my application into this cluster. A few questions if you want to report usage metrics and crashes report. I say yes, but you can say no. And last question is about whether if you want to use Docker Content Trust to sign your images. Here I will default to no. That's it. We've configured App2Container. So the next thing to do is to configure your remote connection. So as Melina said, we can install App2Container on the server running your Java Tomcat application. But as a best practice, I don't like to install tool on the server where my application are running. I do prefer only install what is required by my application. So definitely App2Container is not required by my application, so I don't want to install it on my server. So I will use the remote capabilities of App2Container to analyze my application remotely. So You don't need to provide your the IP address of your server if you don't know the IP address. You can provide the fully qualified domain name. So here I will provide the fully qualified domain name of my Linux server. You can select the authentication method between key or certificate. I will use the key authentication method. For this, I need to provide a secret ARN. So what is a secret ARN? In my AWS account, there is a service called Secret Manager. And the purpose of this service is to store your secret. And I've stored my key inside this inside the service, and the secret ARN is basically the ID of my secret inside this service. So I can grab the secret ARN in the AWS console, and I paste it there, and it's okay. Then App2Container asks you if you want to configure another server. No, I don't want, so it's okay. And it tests if it can successfully connect to your remote server, and here everything is okay, so we can continue. So we've init App2Container, and now we've configured our remote connection. We're good to go. The next things to do is to make an inventory of the application running on your server. So let's ask App2Container to run this inventory. So it connects to your remote server, and it detects if you're running Tomcat, Tommy, or GBoss. And in our case, we are running Tomcat as in server, so it detects our Tomcat installation, and then it detects which applications we are running on Tomcat, and it stores the retrieved application links inside this file called inventory.json. So let's take a look at this file quickly. So here, as we are running only one application on our Tomcat server, in the file, we only have one application listed, and we need to grab the application ID because we will need this application ID in the next step. So basically, we already App2Container already have spotted a few information about our application, the process ID, the command line used to start our application, and the type of application here, Java Tomcat. Okay. So now we want App2Container to take a deeper look at our application. So the next step is really to ask App2Container to analyze our application on our target machine. So we provide here the application ID and the name of our machine as a target. And we can run this command. And here, App2Container start to connect to our server and really to analyze our application, its dependency, the port the application is using to connect to the world, and store all this information in the analysis.json file. So, and we can edit this file. So let's take the time to edit this file and to take a look at it. So here is the file that App2Container has produced after analyzing our application. Okay, so it already has produced a few information to a few parameters to produce our container. It has detected that it will probably create our container on a Ubuntu-based image because we are running our application on an Ubuntu machine. It has detected the process ID of our application, the user ID of the user used to run the application, the group ID, the command line used to start with all the parameters of this, this command line, some information about the operating system, the port used by our application, and the environment, also the environment variables, and the directories it has to grab to grab the file of the application. And just to show you, App2Container may have missed some file, or may have included missed some file, or may have included files that you don't want to include in your container, and you can specify this file here in the configuration. Okay, so okay, let's quit this file. Now that we have run this analysis and we know how the application run on our server, the next thing we want to do is to ask App2Container to extract all the files required to create our container, all the files that are used by our application remotely. So it's basically calling the extract command and giving App2Container the target and the application ID once again. And App2Container do everything for you. It's basically downloading all the file on your local machine. So after this step, everything will run locally on your machine. You don't need to work anymore on your remote server after this step. And what's cool, really cool with App2Container, if you don't know what to do next, when a step is done, it tells you, okay, the next step, you can run the containerize command. So it's really great about, I love this about App2Container. It tells you, okay, next step, you have to run this command. So basically it's super easy because you don't have to think about, okay, what I need to do next. It simply tells you what to do next. So now I will run this containerize command, and it starts checking a few prerequisites. Basically, does Docker run on your machine? And it generates an entry file. So basically, in this file, you will have the commands that will be run when you start your container, when your container starts, and it creates a Docker file. So let's take a look at this Docker file, okay? So here you can see that in this Docker file, we have everything we need to install our application, and even it installs the Openjdk distribution. And we are using version 11 of Openjdk, but we are not using, I know my local farmer is not using the standard Openjdk distribution provided on Ubuntu, but they are using Amazon Coretto. Amazon Coretto is an Openjdk distribution provided by Amazon at no cost with long-term support for every version. So basically, we are still supporting version 8 of Openjdk at no cost. And so we can change the Docker file because it's our, once App2Container has generated this Docker file, it's our Docker file. We can do whatever we want with this Docker file. And so let's edit the Docker file to install Coretto rather than installing the standard Openjdk distribution. Okay. And let's write this. And now we will ask App2Container to rebuild the container for us. Okay. And we don't want to rerun all the steps. We just ask App2Container to build with the build only parameter. We will just build the container, rebuild the container. And while App2Container is rebuilding the container, let's take a look at another file it has produced in the previous step. It's the deployment.json file. So this file basically define a few things for you. So it defines how to, where do you want to host your application? And it gives you 3 options to host your containerized application onto AWS. The first one is ECS. It's another container hosting option on Amazon, but we don't care today. And so we will ask, we don't want to create ECS artifacts, so we will put this to false. The second option is EKS. So yes, that's what that's our interest today. So we will ask to, yes, I want you to create EKS artifact, and we can set up a bunch of parameters. But today we will trust App2Container to make the right decision for us, because App2Container will create a scalable and secure EKS cluster for you based on AWS best practices. So you don't have to change the parameter if you don't know what you're doing. You can trust App2Container to do the right thing for a first experiment for you. So that's everything. We can write this file and quit. Okay. So let's take a look at how it goes. Okay, so it has now it has rebuild my images, and we can even run it locally. So here my my container image is starting on my local machine. So the Docker file I've created has nothing to do with AWS. I can use this Docker file to create my container locally and run it locally, and it's fine. And I can run the same container in any Kubernetes cluster, whether on premise or on AWS. That's fine. So let's let's stop my Docker container. Okay, let's clear it. So now the next step is to ask App2Container to create to really create the deployment configuration file. So let's ask App2Container to create this file, and it currently App2Container is creating two sets of files. First, it will create a EKS deployment YAML file and an EKS service YAML file, where it will define, okay, your deployment, your EKS deployment, and your EKS service. So your Kubernetes deployment and your Kubernetes service, sorry. So that's the first step, first set of files, and you can use this file in any Kubernetes cluster. You are not tied to Amazon EKS. And the second set of file is it creates CloudFormation templates file that you can use to deploy an Amazon EKS cluster on your AWS account. So basically, now everything is ready. So I can use this command, okay, and just add here on which AWS file I want to use to deploy everything into my AWS account. Oh, okay, yes. Because the path has been created with root privilege. So I need to add sudo at the beginning. So, and that's it. And now it has started to deploy an Amazon EKS cluster into my AWS account. And then it will create, it will deploy my application into this EKS cluster. And that's it. We are done. But to be honest, it can take up to 60 minutes to deploy everything, because we are creating a VPC, so basically a virtual network into my AWS account. We are creating the worker node. We are creating the manage control plane. We are creating everything for you, so it can take some time. So I've already run this command before, and we will take a look. So as I told you, we are using CloudFormation. So CloudFormation is a service that we use to deploy our resources on AWS. And I'm in the CloudFormation console, and here in the output of the deployment, I can grab my load balancer DNS name. So let's grab this, okay? Let's grab this, okay? And of course, listening on my application is listening on 8080, and that's it. So this is my application running into my EKS cluster in my AWS account, and it's up and running. I can add a new provider. Okay. So we are the 6th of October. Okay, and it works. So my application is up and running in my EKS cluster. And we can go to the Amazon EKS console. And here I can see my cluster. I can take a look at the overview. So I can see that it has deployed 3 worker nodes for me. I can see the type of EC2 instance it has selected to deploy my worker node. I can take a look at the workloads that are deployed inside my EKS cluster. I can see my Java Tomcat application here. And that's it. So we are done. So I think it's time to wrap up. So just a few key takeaways about App2Container. It's allow you to containerize your existing Tomcat, Tommy, or GBoss application, and it generates your container images that you can use wherever you want. You can also, it generates also your deployment instruction file for Kubernetes that also you can use on any Kubernetes installation. And it deploys on your AWS account with scalable and security best practice. So if you don't know anything about EKS, you can start your experiment very easily. There is also a few key takeaways that you can have in this session about Coretto. Yes, we've used Amazon Coretto. It's an Openjdk distribution, and you can use it. It's multi-platform support, and it comes at no cost. We've used also Amazon EKS. It's like Melina said, it's managed Kubernetes services. And if you don't want to use Amazon EKS on AWS, you can use the EKS distro on premise. So yes. So our advice is just to give it a go and to start with App2Container and EKS. You can just try these 2 workshops. The first one is about App2Container and how to modernize your application with App2Container. And the second one is really an EKS workshop and everything you need to know about EKS from the very beginning to very advanced topic. So that's it. Thank you for joining this session, and if you have some question.
Francois, can you hear me?
Yeah.
Oh, sorry, I had audio problems earlier. So yeah, there were a couple of questions. One was why use, hold on, let me read it verbatim. What are the main differences between Amazon Coretto and Openjdk? And basically yes, go ahead.
So Amazon Coretto is an Openjdk distribution. So basically it's just an Openjdk distribution built by AWS, supported by AWS. It's linked to the upstream. You can get some fix quicker with Amazon Coretto, but every fix we did to Openjdk, we contribute to the upstream. And the difference also is we are still supporting, for example, version 8 of Openjdk. So we really provide a long-term support to each Openjdk version.
Yeah, my understanding that's the main difference. Openjdk is, I think, on a 6-month release cycle. And once they have a new release, they stop supporting or patching the last one. Whereas we keep sort of on top of, security vulnerabilities and whatnot. So it's free. So, you can also use Oracle or whatnot, but, it's going to cost you. So I think those are the main differences.
Yeah, and you can use it on premise. You don't have to use AWS to use Amazon Coretto. It's not related.
Right. And then we have another question, difference between ECS and EKS.
Yeah, so basically they are both, it's 2 orchestrators, and basically ECS is AWS own orchestrator. It's very opinionated and it's well integrated with all AWS services, and EKS is really Kubernetes managed services. So it's really Kubernetes running on AWS, and it provides you with all the choice that the Kubernetes ecosystem offers to you. So it's really up to you to decide whether you prefer to use Kubernetes rather than ECS or both. It's up to you.
Thank you both. Any second.